Retrieval augmented generation, or RAG, is the fusion of infinite information, latest updated information, and the power of language model, giving rise to a new era of problem-solving capability for business. Now, recent algorithmic advancement like replacing positional encoding with alibi, sparse attention, and flash attention 2 and 3 have really extended the allowable context window of language model. But despite these, all the predictions of these technique being RAG killers have turned out to be wrong. RAG is very essential for integrating new information into language models and reducing hallucinations. It ensures responses are based on grounded data rather than assumptions. In this video today, I will discuss a new player in this market, GroundX from EyeLevel.ai. So EyeLevel's GroundX is quite an innovative platform transforming document processing and retrieval for large language models. Their fine-tuned model, trained on hundreds of thousands of documents, expertly handles complex visual elements like tables and forms, minimizing LLM hallucinations. And as per their official blog, the accuracy numbers was this. So EyeLevel GroundX achieved 97.83%. LangChain based on Pinecone achieved 64.13%, and Llama Index achieved 44.57%. And this test involved 92 questions across 1,000 pages of intricate tax documents, the kind of real-world challenges or real-world documents that you will face in the business. Now, discussing about the techniques that GroundX employs to achieve this great result. Number one is the platform employs dynamic chunking and automatic context generation. This preserves the crucial information often lost in regular vector database. So they have a proprietary search and ranking system which outperforms traditional vector similarity search and also ensures accurate content retrieval. And users can ingest documents effortlessly from various sources and formats, obviously. And they have a enterprise grade security with virtual isolation, data encryption, and full user control. And also of particular mention is that they have a unique scoring system which ranks every retrieval result, allowing users to filter out low quality matches and significantly reduce hallucinations in their LLM application. So basically that means GroundX returns a proprietary score for every retrieval that ranks results by their adherence to the question being asked to the RAG system. So I read their white paper and this is basically what I found. Number one, instead of relying completely on cosine similarity for text relevance, which can be misled by superficial semantic similarities, GroundX employs a more sophisticated strategy, helping it to achieve a more robust contextualization. The key innovation lies in how GroundX processes documents. Instead of simple text chunking and embedding, it breaks documents into semantic objects. These objects preserve critical contextual information and are specially designed to optimize retrieval. So GroundX rewrites the document content in a way that improves both retrieval and generation, allowing for the right reference to be retrieved more often and for that reference to be properly conveyed to the language model for accurate generation of the final output. And this approach could be particularly valuable in domains like legal, financial, or technical documentation where contextual and precise interpretation are very crucial. Alright, now let's see the process in slightly more detail. LLMs can only think in small blocks of text. So what many people do in this field is when ingesting documents or databases is to chunk the content into small paragraph-sized blocks. However, when this is done, context of what that chunk is about can quickly be lost. Imagine a random paragraph is pulled from a book and someone is asked to tell what the book is all about. They likely won't know who is talking, what they are talking about, or where they are. They won't know if this is a fact or fiction. They won't even know the content is from a book. Perhaps it's a medical file, a legal document, or a children's social book. And LLMs are faced with the same dilemma, and this context problem is one of the reasons a pure vector approach actually introduces hallucinations into the application. And to solve this, when GroundX ingest content, they then run it through a proprietary AI pipeline that classifies, labels, and clusters the data as it's chunking. This means GroundX extracts the relevant context of what the chunks are all about and wraps each chunk in metadata that describes it. Each chunk gets wrapped with extra information like what the document is all about, who is talking, what are the important issues it's referencing, and so on. And so, to capture all these extra information, GroundX stores each chunk in their database with its metadata wrapper and corresponding vector embeddings. So, this is one step ahead than using just a regular vector store, because vector databases are very good for clustering, which is the process of numerically describing how close ideas are to one another and then storing that nearness as a multidimensional number. For example, the word apple is near the word orange and fruits in one dimension and near the word computer in another dimension. And that's why metadata is so important to contextually understand the meaning of text. But a regular vector store cannot hold the metadata that the text chunks need for context later on. Vectors are important but insufficient to solve the problem fully. So GroundX uses a traditional SQL database structure instead, which allows them to store the text chunks, metadata, and vector embedding all together. This leads to a much more performant semantic search of content when a user asks a question. Alright, now I'm going to show you this amazing product from GroundX named X-Ray, and you will quickly see how they turn complex documents into ready data, ready to be fed into a large language model. So I'm just going to feed it some noisy invoice data, and it will be cleaned up by GroundX immediately. Okay, so this is an example document containing an employment application and some handwritten stuff here, and very unclean, very noisy, and I'm just going to upload it to GroundX. And I just uploaded this document right here by just dragging and dropping, and as you can see, it takes up to 5 pages max, and accepted formats are PDF, JPG, PNG. API takes a dozen formats and hundreds of pages per upload. So this is this particular URL here, it is just for your pre-testing, but remember the API takes any format. And for testing, you can also choose any of these preloaded file, but I just uploaded my this one and click on submit. And it may take a few seconds, maybe half a minute, just to process it, like 60%. And while it's processing, just note that spatial information has to somehow be preserved such that the language model can reason about the figures correctly. So GroundX employs a fine-tuned vision model that can extract high-level document components and then summarize them, allowing GroundX to work well with documents containing visual information. Alright, the document got processed, and this is what it's showing after processing it. Let's zoom out a little bit. So as you can see, there are various segments that has been applied, like this is one segment, this is another segment, and just click on it. And then you will see all these extra semantic object level information about this document that I just uploaded. This is so fantastic. Suggested text. The following text is an excerpt from an employment application form. It includes sections for the applicant's personal information, contact details, and employment history. The text has been minimally enhanced to ensure clarity and completeness while preserving the original formatting and content. This is awesome. So this suggested text is just produced by after processing the document. So whatever it was GroundX understood about this document, that's what it is saying right here, suggested text. All right, and here this is they are giving the exact details of the text. And look at the beauty of the various format that you get after the document is processed. So for example, there it's a JSON formatted interpretation of the entire document. So description, this image contains an employment application for Jane Doe. It includes her personal information, contact details, etc. And then in the perfect JSON format, it gives all the details that was parsed from this document. Similarly, I can click on extract text. That will give you the extracted information. File summary. This document describes an employment application. Keywords. Okay, they are extracting the keywords as well. Employment application, Jane Doe, job history. File keywords. There it's giving some keywords from the file. Employment application, job application, Jane Doe, personal information, contact details. Beautiful. This is just so brilliant. From a single document, you get so much information properly formatted, just the way that a language model will like it. So as you saw with documents like invoices, financial report or accounts, etc., the first issue with regular LLM is the classic GIGO problems, that is garbage in, garbage out. Because LLMs need to be fed simple text. Formattings like tables, headers, tables of contents, columns, and many other things confuses them. Information inside the graphics also will not be processed or understood by regular LLMs. And the current OCR algorithms mostly don't solve the problem. So documents like legal transcripts, corporate filings with heavy financial tables, these are nightmares for regular large language models to process. Even documents that seem simple to the human eye, for example, a magazine article with multiple columns, tends to choke both OCR process and the LLMs. Some of these might be improved by multimodal capabilities that OpenAI and others are providing. For example, the ability to ingest and interpret images, videos, and audios, and so on. But those systems are not in the market at scale yet. So to handle these issues, GroundX built a parsing engine that transforms documents into simpler formats for large language models. So GroundX has a library of parsers based on their past work and a scripting language called GroundScript that makes it very straightforward to build a new parser all by yourself. So that means when a client comes to GroundX with a new document type, they can build a new parser for that new document type with the usage of GroundScript. And otherwise, GroundScript is also just an open platform. Anyone can write a parser for their own projects or to help others. And also check out their official site. They have pretty exhaustive documentation and blogs, etc. To explain every parts of their offering. And yeah, so this is RAG, Made Truthful, etc. These are all the blogs, and this is their pricing section. And also check out their GitHub, GroundX SDK. So here, this is the Python and JavaScript, that is a TypeScript SDK. So with this, you can integrate GroundX with your own code base or your own application.